I think you'll probably find this chapter easier than the last one for a lot of people. It's at least going to be different, that we're getting away from kind of that geometry picturing stuff into more of what a lot of you maybe call math, or like into more algebra. Actually, that's in the title. So chapter 10 is algebra. But don't let that word mess with your head. You'll be fine. Functions and relationships. A lot of times they write books, math books, in a way that they know you're not going to make it to the end. So closer to the end of the book, probably especially chapters 11, 12, and maybe 13 if they have it. It's kind of like just a bonus if you can get to it. I kind of think this chapter is kind of like that a lot of the stuff in this chapter is stuff that popped up in Algebra 2 when I taught that for a bunch of years. It's going to be stuff that you see next year in algebra. So it's kind of if you get it now, it's just going to make next year easier. Because then when it gets reintroduced next year, you'll be like, oh, I remember that from Falk's class. Then, all right, so this first thing, this is probably the biggest part of the section. So I'm going to put a double star by it. It's something that's maybe going to feel confusing at first, but we're going to do some examples, and I think that'll help. But there's this term that comes up, this topic that comes up, and it'll come up in algebra, it'll come up in algebra 2, but a function. Kind of like, when is an equation a function, or when is a graph a function? And we're just going to, today, just kind of like start looking at it, like with data tables, pretty much. But so if you can learn this now, it's going to help you for down the road. So first of all, a function is just a relationship. And if you think of a graph, and I wouldn't draw the graph, I wouldn't put in the equation or whatever I might put in here, but if you have like a graph of, say, something like that, a line, that line is made up of all individual points, right? And each one of those points has like an x value and a y value. So maybe you have something, and I wouldn't be writing all this if I were you, but maybe this one here is like a 4, 5 or something for that middle point there. And what that is that's just a relationship. It's saying when x is this, when x is 4, y is 5. Or if you have an equation where you get like maybe y equals, in this case it'd be like an x minus 1. I wouldn't write this either, but that there's going to be an equation of a relationship. So when a function is a type of relationship, it's just saying some like pairing of x and y, some way to connect them into like points or something. Fair enough? So don't be intimidated by that. A relationship where each input when we have an equation like this, usually we put a number in for what variable and then find what variable. Usually put a number in for x. So the input is, I'm just going to write in parentheses that is each x value. And sometimes you'll have like some other letter than x in there, but typically it's going to be the variable that's like sandwiched in with all the numbers, not by itself. The other side of an equals. So it's going to be a relationship, a connection between x and y, where each input or each x value can only have one answer. Or I'm sorry, can only have one output. And the output, when we put something in for that x value, is going to be our y value. So I'm going to add, after output, like some y value. So that's a function. A function is going to be something like with an x and a y, or maybe two other variables, where whenever you put a number in for x, you could only get one possible y value for that x. And let's look at a couple things. The first thing, and you could write this if you wanted to, you could skip it. I'll maybe write it and say, okay, example 1. But I'm going to just take some random equation, y equals 3x plus 2. And our book gives you something at the very beginning of the assignment that says, okay, here's the rule, but they write it out in words. That an equation like this is kind of like a rule. It's saying if you have an x value, this is what you do to the x value. That this 3x plus 2 is kind of like the rule, you could say. Do you agree if I put a 1 in for x? Well, if I put a 1 in for x, I get what for an answer? 5. Do you agree if I put a 1 in for x, the only possible answer I could get is going to be a 5? You can't put in a 1 and come up with like a 7 or a pi or something. So this one here is going to be, because it's that way for every x value, you put in a 2 for x, you put in a 7 for x, you put in a 6.5 for x, or 0 for x. Each number for x is going to have its own y value. Each number for x can't have two different y values. So this thing here is going to be a function. And we're not, so that's the function. If you wanted to, you could look at it as though this whole thing here is kind of like the rule. I don't know if this is going to help a ton, but it's more specific for like our assignment. But the rule is what they do to x. The x value is the input, and the y value is the output. I think the homework is going to be a lot easier, and I've been trying to drill this in your head in this last week. Write out the equations. A lot of people are trying to do a lot of math in their head. Writing down your work, writing the equations is typically going to be the easier way to do it. I think with kind of growing up with like being told not to use calculators for so much stuff, you guys are kind of in that do math in your head. You're getting to math where we let you use calculators because it's just beastly and too hard to do in your head. So write the equation, use a calculator, solve the equation. I think you're going to find that helpful. Fair enough to move on? Okay. Now, let's look at some that are a little bit more specific to our function things. So my example 2, I'm just going to make a little data table. And I'm going to make it horizontal just for space sake. First row is x, second row is y. And I'm going to throw some points in there. So my first x is 3, my y value is 3. So in other words, you could say there's an equation that gives you this. When you put a 3 in for x, it's going to give you a 3 for y. Fair enough? So far it's a function. You put in a 3 for x, you get 1 y value. If I were to say 4, 7, still a function? Yes. Well, to check if it's a function, you just need to look at, does each x have only one y? So here, each x value has only one y for an answer. If I were to give you then like, I don't know, a 1 and a 2, something like that, and so still a function? If I were to add a 3 and a 4, function, not a function? Not a function. So now officially it's not a function. Because basically it's this point here and this point there. You can say when x equals 3, you have 2 y values. So when x equals 3 has 2 y values. Maybe I should say 2 different y values. That'd be better. So when x equals 3, bad English, has 2 different y values. Actually, that's just kind of bad all around. Let's try that again. Feel free to not change yours, but it's going to drive me crazy if I don't fix mine. So not a function because when x equals 3, maybe I should just say there are 2 y values. So there are 2 different, that'd be even better, y values. Okay, now is that clear? So example 3. Let's say you have a scenario where you buy 1, you get a 4th thing free. I'm sorry, no, that doesn't make any sense. Buy 3. So buy 3. That'd be awesome. Buy 3, get your 4th free. And I didn't really say what they were. We'll maybe say they're widgets. You're buying widgets, whatever they are. A widget, it's the thing with the stuff, you know. Yeah. What, you don't know what a widget is? Okay. All right. No idea. I just made it up. Okay. So if you buy 1, maybe I should put in a cost. What's these things going to cost? $25. Some expensive widgets over there in the Mast household. All right. So if you buy 1 widget made out of solid gold, you have to pay $25. If you buy 2 widgets, you have to pay $50. If you get 3 widgets, you're paying $75. Still a function? Okay. Now, your 4th widget is free. So it's still $75, yes?
Yes, so it's not a function.
Okay. It's tempting to say it's not a function. Perfect. If you go back to your function definition, each x can only have 1 y. So in this case, even though I have my y being repeated, I have 2 75s right here, each x only has 1 y. When x is 3, the cost is going to be 75. When x is 4, the cost is still going to be 75, but it's not like 3 of them could cost me 75 or 80. Or 4 could cost me 75 or 100. The 4th one's free, so it's just 75. We okay on that? All right. Last example. Oh, it's kind of a 2-part one, in all honesty, so I'm not cheating. All right. So I have, this should be example number 4, right? Yep, example number 4. Let's say you're babysitting. I was told $8 an hour is the going rate.
Oh, mine's like $5.
5? Maybe they just figured my kids were going to be awful. But okay. So we'll say $8 an hour.
My mom used to be like $1 an hour. Dude, that's higher than minimum wage.
$8 an hour is higher than minimum wage. Some days at home it would. Okay, I should just focus. All right, $8 an hour. Do you agree you could take the equation and say something like the pay is going to be what? What's kind of the rule for pay? 8 times some variable. Could do an X, could do an H for hours. It doesn't really matter. I'll maybe put in the H because we didn't use a Y either. But pay equals 8 times H, something like that. For this here, we haven't really looked at how can you tell if a graph is a function or not. But one way you could check and see is this going to be a function is to go through and put some numbers in a data table. I probably should use P and H. So my independent, you put in a number for H, so that'll go in the top row. The dependent is capital P, the pay. So if we pick some numbers, if you babysit for 1 hour, you're going to get paid $8. 2 hours, 16. Should we do a 2.5 just to make your brain work a little bit more?
No, we're about to
2.5 is going to be 20. So you could go through like with a data table like this. Are we going to end up getting one X value that has 2 Y values? No. So this one here we know is going to be a function. Because it doesn't matter what we pick for X. It's never going to possibly have 2 different Y values. Now, here's getting back to that whole, please show your work, please do it the easy way. So I'm going to say kind of, well, maybe I should just make it a different example. Example 5, why not? Example 5. Let's say you were paid, or you earn $67. How long did you work? So still using the numbers from example 4. If you were paid $67, how long did you work? And you could go through and you could say, okay, 67, 8 times what is close to 67, and try to do all kinds of working in your head. But I think it's going to be easiest if you just start with this thing right here. If you start with a rule, if you start with the equation. If we have P equals 8 times H, where do we put the 67? Is 67 the P value or the H value? It's the P. It's how much you got paid. So 67 equals 8 times H. And now to solve for H, you would just, divide both sides by 8. And that isolates the H. So now if you punch that into a calculator, you're going to end up with, you end up getting H being 8.375. So 8.375. And that the units for that would be hours. Focus, we're almost done. We're almost done. But you just solved for H. H was the amount of time you worked, so H was the number of hours to get the $8 an hour. So you would have to work 8 3/8, or 8.375 hours to get the answer. Any questions?